Okay, here's the video of the solar biodiesel stuff. This is the array. There's a few prototypes. There's some of the sealing systems, prototype sealing systems. I'm gonna go with that one and that one and test them in the field. That's an assembled unit. That's the locking color. It works with either the gray or the black PVC. And you can see all the tubes and the quick fit fittings. I've talked about that before. What I've got now is okay, here's a clear unit. So up here we've got a rubber bushing. It's a reducing coupling that we got from a hardware store. I think it goes from 2 inch to like 1.5, but I cut that 1.5 section off from here. So what you're seeing here is a black rubber stopper that's turned upside down, and it's got the stainless steel tubes passing through it into here. So I'll just briefly show this. So there's a fully assembled clear. This would be the receiver from the raw inputs. And then over here I've got a partially assembled prototype example as well. You can see the same rubber stopper here. It's not yet sealed because I need to get another one of those reducing couplers. At any rate, you can just see that it's just sitting on top of it, and it'll be held concentric and held down and sealed against that by the coupler. So what we got in here is, at the top there's a wiffle ball, there's a stainless steel slinky toy, at the bottom another wiffle ball, and a plug. This is just a prototype. So the intent is that it would be resting at its side at about 45 degrees. The long tubes inject the light-based components, so actually you can't really see it right there. That's the injection point for methanol. So what happens is it shoots down about 18 inches, and I've measured this, and then it turns around and floats back up. So that increases the effective path length of the reactor. And as it floats back up, it'll float up at the top side, and it'll cause that to kind of oscillate and vibrate. And so I'm hoping that that would give a good mixing motion. But then by the time it comes up to here, you want things to phase separate again. So the wiffle ball is what's called a coalescence. It's a coalescer. So it slows down the flow of broken up droplets and allows droplets to recollect into bulk liquid. So you should have, a methanol air gap, a gas gap up here, clear methanol. This would be the second tube in this test array, so I'm not expecting much biodiesel yet, but I am somewhat optimistically. I do have a low pickup point down there to pick up any potential glycerin, or at least to allow it to collect so that I can measure the rate production. And if I get that, I'm expecting mixed monoglyceride, diglyceride, unreacted oil, and biodiesel, which kind of forms a milky mixture, which will get picked up here. There's a pickup right there, and eject it out to the next tube where it will have another chance to react. So it's a cascade reactor. Just keep passing the contents from one tube to another and just keep reacting them. Of course, the reason I did this in clear is so that I can see what's going on. The difficulty is I don't have a good way to heat it. So I'm going to form a box section around the clear tubes over there of reflective material, and just use this infrared heat lamp. It's just a standard bathroom 250 watt heat lamp, which simulates how much solar energy the same square footage of area would capture. And then over here I'm prototyping, and it's very ghetto because I did this in about 5 minutes and didn't really take time to do it carefully. Just the point of, would I be able to still see what's going on by leaving a strip exposed, a visible strip? And this one could use work. It's just another concept for the test reactor. That's the basic thing. Those are the materials of construction. Here's a plastic tube example. Same thing though, slinky tube. So that's the work in progress. All right.